Hi, it's Mr. Duffy. Welcome to chemistry. In the video you just watched about Bohr models, it talked about how Bohr models were found, and it didn't really talk about how to represent or draw a Bohr model. So this video I'm going to make shows you how to show and represent where the electrons actually are in around the nucleus of an atom, and again to represent a Bohr model. So this video actually encompasses the first 3 answers on your actual worksheet, so you can actually use this video to answer the first 3 questions. So like I said, in the video I didn't show you how to draw a Bohr model, how to represent where the electrons actually are. But so to do that, we need to know how many electrons can go in each of the energy levels. So in the first energy level, we can have 2 electrons. In the second energy level, we can have 8 electrons. In the third, we can have 18. And in the fourth energy, we can have 32 electrons. 32. Now, after that, there are, again, additional energy levels, but we do not need to know. We're not going to go anything beyond the fourth energy level. So we just need to know that, again, 2 can go in the first, 8 can go in the second, 18 in the third, and 32. You're never going to get an answer that has, a 5th energy level that you would have to fill up and so forth. Okay, so to do these first 3 problems, we first have to know how many electrons each one of them has. So we're going to look at sodium, potassium, and hydrogen. To figure out how many electrons it actually has, we have to use the periodic table. And so we have sodium, potassium, and hydrogen. Sodium is element number 11, so it has 11 electrons. Potassium is 19, and hydrogen is 1. So in my worksheet, I'm going to write that right down on the line, 11 electrons. Potassium had 19 electrons, and hydrogen just had 1. I think I'm going to start with hydrogen just because it would be the easiest. Since hydrogen only has 1 electron, it would go in the first energy level, and we'd write it something like that. So hydrogen, just 1 electron. There's, again, 1 proton in the nucleus. The nucleus is represented with that black dot. So again, electrons, 1 electron in the energy level there. Now, let's go back to sodium. Sodium would be the next easiest since it has 11 electrons. The first energy level, we have 2 electrons. So we do 1, 2 electrons. The second energy level can hold 8. I still have 9 left to use because I just used 2. So I'm going to do 1, 2, 3, 4, 5, 6, 7, 8. That's the second energy level. Now, if you noticed how I filled them in, I did kind of like 1 on the top, 1 on the right, 1 on the bottom, 1 on the left, and then I paired them up afterwards. You don't have to do this as you're going through, but the reason why I do it that way when I fill up the energy levels is for a topic that we're going to talk about next week. So again, it has to do with the quantum model of where the electrons are. Don't worry about it for now. That's just the way I do it. The final electron goes in the last energy level. You can just put it in the third energy level anywhere. And now we've used 11 electrons, and so that sodium atom, the Bohr model, is done. Okay, finally getting to potassium. So potassium has 19 electrons. So we're going to do 1, 2 electrons. Then we're going to do 1, 2, 3, 4, 5, 6, 7, 8 electrons. There I've used 10 electrons so far. And then finally, in the third energy level, it can hold 18 electrons. So I'm just going to go ahead again and fill in 1, 2, 3, 4, 5, 6, 7, 8, 9 electrons. That's all that I had left. I had 9 more electrons to use, and that's 19 total electrons there. So there's an extra ring basically on this one. So that's how we draw the Bohr model for our electrons. Hopefully this was helpful.